All right, so in this video we're going to use the binomial theorem to expand a binomial. And here I have x minus 2 to the fourth power. And the binomial theorem tells us how to do exactly that kind of thing. So what is the binomial theorem telling us to do? Well, it says to take a sum where k ranges from 0 to n. And then what's this quantity? Well, this means n choose k. N number of ways we can take k things from n objects where order doesn't matter. So if you watched my previous video, the notation I had for that was c of nk. It's the same thing. This is just a shorthand notation to denote that. So it's a number of ways we can take k objects from n objects when order doesn't matter. And we had a formula for that. It's n factorial divided by n minus k factorial times k factorial. That was the formula. Okay, so that's what this means. And then we've got these pieces raised to these exponents. So that's what we got to do here. We've got to apply this formula. Okay, so let's get started. X minus 2 to the fourth power. Well, what does the formula say to do? Well, it says to take n choose k, right? Where k starts at 0. Now, n is the exponent, right? So my exponent's 4. I'm starting with k equals 0. So I'm going to start with 4 choose 0. Now, over here, I got x to the n minus k. So that's x to the 4 minus 0. And then I have y to the k. So in this case, my y is a negative 2. So I have negative 2 to the 0. Okay, my next term, I'm going to increment k to 1. So I'm going to have n choose 1. So I get 4 choose 1, x to the n minus k, so that's 4 minus 1, and then y to the k, so it's negative 2 to the 1. All right, cool. My next term, I'm going to increment k one more time, so now k is equal to 2. Right, so I have n choose 2, so I have 4 choose 2. X to the n minus k, so 4 minus 2. And then y to the k, so negative 2 to the 2. Okay, now I'm going to have to go down to the next line here. Plus, what do I get? I'm incrementing k one more time to 3. So I have n choose 3. So that's 4 choose 3. X to the n minus k, so 4 minus 3. Negative 2 to the k, so negative 2 to the 3. And then I increment k one more time, so k goes to 4. So I have n choose 4, that's 4 choose 4. X to the 0, right, because n minus k is 4 minus 4. And then y to the k, so it's negative 2 to the 4. Okay, so that's how I expand it out. Now I have to, let's simplify all this. Some of these things can be expressed simpler. What are these? Well, I've got to compute this for each one of these, right? Okay, so to compute 4 choose 0, I'm going to take 4 factorial, divide by 4 minus 0 factorial times 0 factorial. Now, 4 factorial divided by 4 factorial is just 1. Now, what's 0 factorial? Well, one important thing that you should keep in mind is the definition of this is just equal to 1. Now, that may not seem obvious at all. Like, why would 0 factorial be equal to 1? Well, that's how we define it. All right, so you see that this whole thing just ends up being equal to 1. Okay, so what about 4 choose 1? Well, that's 4 factorial divided by 4 minus 1 factorial times 1 factorial. So divided by 3 factorial times 1 factorial. Now here we can use a little trick. 4 factorial is 4 times 3 times 2 times 1, and 3 factorial is 3 times 2 times 1, right? Now let's write down the 1 factorial, that's just 1. But see, a lot of these just cancel. Right? So it's really just equal to 4 over 1. It's 4. So a lot of these will simplify considerably when you use this trick. Okay, 4 choose 2. That's going to be 4 factorial divided by 2 factorial times 2 factorial. Well, again, the same trick. We go 4 times 3 times 2 times 1, but 2 factorial is 2 times 1, right? And then that 2 factorial is 2 times 1. So these cross out. So I get 12 divided by 2. That's just equal to 6. Okay. And what about 4 choose 3? Well, that's going to be 4 factorial divided by 1 factorial times 3 factorial. Well, that's the same as this, right? So that's equal to 4. And then 4 choose 4 is 4 factorial divided by 4 minus 4 factorial. It's 0 factorial times 4 factorial. Well, and again, as we did over here, that's equal to 1. Okay, so we've just figured out what all of these are. So let me take that away and we'll write that in. So we have 1 x to the 4th plus. Here we found that this was equal to 4, so we have 4x cubed times negative 2. And over here we found that this was equal to 6, so that's plus 6x squared times negative 2 squared is 4. Okay. Over here we found this to be equal to 4, and negative 2 cubed is negative 8. And then finally this we found to be equal to 1, x to the 0 is 1, so we just have negative 2 to the 4th. Oh, right. That's equal to 16. All right, so let's write this out. So x to the 4th minus 8x cubed plus 24x squared minus 32x plus 16. And we're done. Now let me show you one other trick here. Figuring out these coefficients, there's a when these numbers are small, there's a trick you can use to do that, and that's called using Pascal's triangle. So Pascal's triangle is a triangle that you can form just by starting with the numbers 1, 1, 1. Put them in a little pyramid like this, and then each row below this, just start with a 1, and then every subsequent number is the sum of the two numbers above it. So 1 plus 1 is 2, and then we end with a 1. And then we start with 1 again. 1 plus 2 is 3. 2 plus 1 is 3, and then we end with a 1. And we start another row. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then we end with a 1. So I can just keep going with like this and just generate this going down, down, down for infinity, right? But if you index these rows 0, 1, 2, 3, 4, the row that we're on gives us the coefficients that we need corresponding to that exponent, right? So when we had exponent 4, this is giving us the values of these coefficients, which we went and kind of painstakingly computed that using factorials and stuff. But you'll notice that 14641 is exactly the numbers that we had here. So actually Pascal's triangle gives us kind of a quicker way to get at those. Now that works when these numbers are relatively small. If we had to go to, if we had an exponent of 26 here, I don't think you want to write out the triangle to 26 rows. It's probably easier just to use the formula, right? But this is a nice little trick that you can use if the exponent is small.